Okay, now the topic is vent system, plumbing vents. So dito sa picture, makita mo yung parts ng plumbing. So itong water meter. So other topic to, water supply to. Then ito naman yung drain. Clean out, house sewer. So yung mga vent mo, nakakonect sa drainage. Yan, mga vent yan. So maraming klaseng vent location kung saan mo lalagay. Sa mga type, merong yung vent, marami pa yan. So, start na tayo. Vent system. So, the flow of air is the primary consideration in design of venting system for the ventilation of the piping and protection of fixture trap, seals, or sanitary drainage pipe. Take note, venting system, ventilation system, supply and exhaust ng area. Hindi yung exhaust lang. Lalabasan ng hangin, kundi pasukan din ng hangin. Vent. Ventilation, venting. Since air is of such primary importance, it is essential that the plumbing engineer be familiar with certain physical characteristics which are pertinent to its behavior in plumbing system. Vent stock. Una natin yung vent stock. Paatas tayo, di ba? Yung mga sa pag-design, siyempre mag-umpisa kayo sa dulo. Papunta dito sa main pipe. So ito yung main pipe niya is yung vent stock. Dalawang klase yan. Hindi, isa lang pala. So drainage yun. So dito, every drainage stock should be extended full size to the roof. So the pipe from the topmost drainage fans connection to the roof to the atmosphere is called the vent extension. Ito. So wala sa figure, no? So ito, okay, ito, vent stock to roof yan. So pag mayroon ka ditong ito, last mo, pag nag-extend ka dyan, wala pa to, ito lang. Ang tawag doon, vent extension. Yung sa baba niya, yun ang soil stock. Pwede yun. The vent extension provides the air which is dragged down the stock and also provide means for gravity circulation of air to the system. Vent extensions may be connected with the vent stock before extending to the roof or may be connected together with other vent extension or vent stock in a vent header and extended through the roof as a single pipe. Ito yung binabanggit na yan. Ito yung vent header. Through the roof. Pwede yan. Depende nga sa layout, sa plano mo, sa layout. Kung pwede, so kung may mga harang, so hindi pwede diretso mo na lang. Okay? Figure 1 illustrate acceptable methods of vent stock connection. So this is yung various vent stock connection. So ito. Isang drain, tapos ito yung soil stock, then vent stock to roof. Pwede rin dito. Vent stock connects below lowest branch, then pataas na. Okay? So lagi siyang after nito. Yan, after din siya dyan. Ito, sa taas, ito yung sa ibabaw niyan. Ito yung last sa pinakataas mo. Last floor, the drainage. After niyan, doon kapag pwede ka mag-tap doon. O pwede mo rin siyang iiwanan. Kung isang butas lang ang kaya ang pwede, so dito pwede ka mag-tap dyan. Side. Ito ganun din. Common. Vent header ang tawag na. Okay? So, vent terminals. Ito yung mga vent terminals, common vent terminals. Naka-ano siya. Sa mga drawing, makita mo straight lang. Pero ang actual niya, naka-bend siya. Kasi nga, yung ulan, pag naka-open siya dyan, papasukin ng tubig yun. Yan ang purpose niyang bend na yan. Gooseneck. Vent terminals should not be located within 10 feet of any door, window, or ventilation intake unless they are extended at 2 feet above such opening. Yan. Kasi magkakaroon ng impact yun. So, pag nagmalapit siya sa ventilation intake, papasok yung amoy doon. Terminal should be at least 6 feet above, 6 inches above roof level and at least 5 feet above when the roof is used for other purposes. When it is impractical to extend the vent to the roof, it is permissible to terminate through a wall, but the terminal must torn down and be located with a wide screen. A terminal should never be located beneath a building overhang. Next is the fixture trap vents. Ito yung ang concentration ng mga vents dito. Kaya nga meron tayong vent. Nandito kasi yung purpose niya. So the water seal of all fixture traps should be protected against siphonage, sigop, or blowout by the proper installation of venting system. Where drainage stacks are provided with adequate supply of air at the terminal, and an adequate vent stack is provided to relieve excess pressure at the base of drainage stack. The only additional vent protection required to prevent water seal loss and friction trap is that necessary to prevent self-siphonage when the fixture discharges and to relieve excessive pneumatic effect in the branch line when other fixture discharge into the branch. Some municipalities require that every fixture tap should be individually vented, but most localities permit alternate methods such as a wet venting, 2 stack venting, 3 circuit and loop venting, 4 combination waste and vent venting. Yeah. So, ibang mahigpit, gusto nila talaga individual ang vent ko ng laboratory, water closet. Sa atin, wala ka na. Kung ano yung available. Ano yung design mo. Kasi hindi mo na susunod yung mga drawing dito. Ikalat-kalat yung mga CR sa atin. So combination way, the vent stack should extend undiminished in size to the roof or connect with the vent extension or the drainage stack at least 6 inches above the overflow of the highest fixture or connect a vent header. So in-extend mo siya, dapat same size pa rin. Ito yung mga trap seal reduction from 1 inch positive, trap seal reduction from 1 inch negative pressure. So notes, trap at rest with 2 inches trap seal, yan, 2 inches yan. 2, itong 2, trap subjected to 1 inch suction from building drain piping. Nasak siya. So, tataas to. Pababa siya ng 1 inch. So, pag tanggal yun, pagbalik number 3, trap at rest with 1/2 inch loss of trap seal. The trap will continue to spill over and lose trap when subjected to 1 inch suction until the trap seal is reduced to 1 inch. The 2 inch initial trap seal permits the trap to withstand 1 inch suction and still maintain a trap seal of at least 1. So, ito, ganun din. Number 2, ito, trap subjected to 1 inch positive pressure from building drain piping. So, ito naman, force to. When the pressure is removed, some spill over occur from the momentum of the trap legs equalizing. Kapag nawala yung pressure niya, so, siyempre babalik to bigla. So, magkakaroon ng overflow, spill. Or trap will continue to spill over and lose trap when subjected to 1 inch positive pressure until the trap seal is reduced to 1 inch. The 2-inch initial trap seal permits the trap to withstand 1 inch positive pressure and still maintain a trap seal of at least 1 inch. Okay? 1 inch negative pressure, 1 inch positive pressure is a unit of water gauge. Next, distance of bend from top. So the maximum recommended maximum distances of a bend from the weir of the top to the bend connection are tabulated in table 1. So picture mo ay 1 and 1/4, so 30 inches ang maximum distance. 1 and 1/2, 42 inches. 2 inches is 60 inches. 3 inches, 72 inches. 4 is 120 inches. So this is the maximum distance. Pag nag-tap ka ng bend, yan. Ito yung distance niya hanggang dito. So, meron din minimum yan. So various method of fixture trap bending. Figure 2 illustrates various fixture trap bends and their proper nomenclature. When bending one trap, the bend is called an individual or back bend. Ito. When bending one trap, the bend is called, if pictures are back to back or side by side, and one bend is used for the two trap, the bend is a common bend. Any connection from the bend stack is a branch bend. Ito. Okay. All bend piping should be graded to drain back to the drainage piping by gravity. The bend should be taken up above the center line of the drain pipe and rise vertically at an angle of not more than 45 degrees from the vertical. The horizontal line of the bend should be at least 6 feet above the overflow level of the fixture, so figure 3. Ito yung pitch niya, yung drain, yung bend mo pag gano'n, so nagtataas siya. Kasi para yung kung ang liquid pa dyan, mag-drain back. So, may maximum 45 degrees. Yung mga horizontal line of bend. Relief bend. Ano yung relief bend? Pressures in the drainage and bend stack of a multi-story building are constantly fluctuating. So the bend stack connection at the base of the drainage stack and the branch bend connection to the branch drain cannot always eliminate this fluctuation. It then becomes extremely important to balance pressure throughout the drainage tract by means of relief bends located at various intervals. The fluctuations in pressure may be caused by the simultaneous discharge of branches on various separated flows. So ito yung bending for stacks having more than 10 branch interval. So more than 10. So ito yung mag-umpisa ka sa taas, ang bilang ng branch interval, yan. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ito yung 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So ito yung 9, ang layo. 10. So yan. After 10, maglagay ka na ng relief bend. Yan. Okay. Tapos yung mga bend nito, naman dito, ikabit mo dyan. Okay. Tapos, next 10 naman, 1, 2, 3, 4, 5, 6, 9, 10. So, kabit ka ulit yan. Tapos, last, si total of 23. So, last na to. Nag-offset siya. Dito mo na papasok yung mga benta. Okay? Sa mga high-rise to, kasi typical yun, high-rise. So, drainage stock in building having more than 10 branch intervals should be provided with a relief bed at each 10th interval, counting from the topmost branch downward. Nabi ko nga. The lower end of the relief band should connect to the drainage stock below the drainage band connection, and the upper end should connect to the vent stock at least 3 feet above the floor level. Si figure 4. Nauna yung explanation ng figure. Relief bands are required where a drainage stock offset at an angle of more than 45 degrees to the vertical. Such offset are subject to high pneumatic pressure increases and extreme surging flow conditions. The method of installing relief bands are illustrated in figure 5. So, sa mga offset na nakita nyo dito sa baba. Yan. Tuloy yan. So, dito sa una, yung vent stock for upper section may serve as the relief band by connection to the base of soil stock for upper section. So, ito yan. Ito naman, relief band may be continuation of soil stock or relief band alternate connection below offset. Yan. Pwede ka mag-down, pwede ka dito. Ito pang isa. Ganun din. So, ito naman, may karog pang papusahan na pwede ka magdugtong yan. This bed stock must be sized for total load connected to soil stock, upper plus lower sections. Ang allocation yan ng bed stock. Ito, obligado ka dyan, saka ito obligado ka dito, at this one. So, ganun din. Yan, pwede mo ito option dito. Daming method. Next, continuous bending. Ito na nga yan, continuous bend. A system of individual or common bends for every trap is called continuous bending. Every fixture trap is provided with a bend. It is the most expensive but provides positive protection of all traps. And patuloy mo yung bend niya. Ito yung fixture, sa side mo lalagay ka ng bend. Wet bending. A wet bend is a bend that bends a particular fixture and at the same time serves as a waste to receive the discharge from other fixture. The objective of using wet bends is to minimize the bend piping required, employing one pipe to serve two functions. There are 3 fundamental rules to follow when utilizing a wet bend. So ito yung wet bending at top floor. Yeah. At top floor, no more than 1 EPU is discharged into a 1.5 wet bed, not more than 4 EPU into a 2 inch wet bed. Yun yan. Ito yung wet bending at top floor. Ito yung papunta sa baba, sa taas mo, so benefit siya. Yung stock bend, ito yung bend stock. Ibang pagpaparas nito. Ito, dalawa na. Ito naman, yung water closet ito, ito yung water floor drain. O, ganyan ito. Yan. Ito, nag-top dito. Pwede rin yun. So, iba-ibang klase ng ito parehas. Ito lang na iba niya dito. Yan. Length of drain does not exceed maximum permissible distance between trap and bend. Branch connect to the branch connect to this track at water closet connection level or below. Okay, pinatang ko lang ng figure 6. So ito yung tinatawag na wet vent. Yan, yan. 2 inches wet vent, kasi dalawa yung sink. Kung binabanggit ditong 1.5 wet vent, ang type niya is steel, GI. Okay? Pag PVC kaya, ano nga, di ba pinakita ko yun? Ang available, pipe or check event, na pang drain is 2 inches pinakamas liit. Yan. So yun ang ginagamit ko, 2 inches. Okay? So ito wet vent siya nito. Halimbawa ito, for bath o for shower, ito shower to. So ang vent niya, ito na rin. Naging, yan, kasi sinabi, for a particular fixture, ito yung vent, para dyan. Nag-receive naman siya ng discharge dito sa laboratory. Okay? So yan ang ibig sabihin niya. So, pwede yan idugtong mo. May vent ka na. Yan. Para dito. Okay? At the lower floor, the rolls are the same except the water closet must be vented and the width vent must be 2 inches minimum. Water closets below the top story need not be individually vented if a 2-inch wet vented pipe connects directly to the upper half of the horizontal water closet drain at an angle no greater than 45 degrees from the angle of flow. See figure 7 for illustration 8. Edit lang yung mga copy-paste error. Okay, ulitin ko to. Water closets below the top story need not be individually vented if a 2-inch vented waste pipe connect directly to the upper half of the horizontal water closet drain. So yan, at mataas yan. Hindi na kailangan. So ito kabila is mababa. So kailangan mo ng vent. Stack venting. So yan. Stack venting finds its general application in one family homes and the top roof of multi-story building. Sa top lang, sa top. Okay yan. Pag meron kang baba pa dyan ng mga floor, so magtatap ka na dito sa gilid. Kasi nga, yung nagsasalubong, pag isa lang ganyan, yung problema nun, nagsasalubong yung drain sa yung vent. Wait, So, where two fixtures, common vents, where two fixtures are connected to a vertical band at the same level, a common vent may be employed. When one of the fixtures connects at a different level than the other, observe the following procedure. If fixture drains are the same size, increase a vertical drain one size. If fixture drains are of different sizes, connect the smaller above the larger connection and maintain the vertical size up to the top connection. Now, test of plumbing system. The complete storm and sanitary drainage should be subjected to a water test and proven watertight upon completion of rough piping installation and prior to covering or concealment. The test pressure should be a minimum of 10-foot column of water, except for the topmost 10 feet of pipe. The test pressure should never exceed maximum of 100-foot column of water. Any greater pressure will cause lead vents to deform and blow, as well as probably blowing the test plug used to seal temporarily open piping in the system. So, if the system is higher than 100 feet, testes may be installed at appropriate height so as to test the building in section. Very rarely in practice are more than 7 stories tested at one time. If it is not possible to perform a water test, an air test is acceptable and is performed at a pressure 5 psi. Air tests are very impractical and usually very costly. Upon completion of the sanitary system and after all fixtures are installed with tap filled with water, the system should be subjected to an additional test and proven gas type. A smoke pressure test is recommended. A smoke test is performed by introducing pungent thick smoke produced by smoke bomb or smoke machines. When smoke appears at the roof terminal, its terminal is sealed and a smoke pressure of 1 inch column of water is maintained to prove the system gas type.